Thank you for coming to my presentation. My name is Hiroaki Ayabe. Today, I will present about an interesting study entitled Elucidating the Effect of Diagram Use Training for Math Word Problem Solving, conducted with Professor Emmanuel Manalo and Ms. Noriko Hanaki. Now, let me begin. It is important for us to develop skills in solving math word problems. However, the correct answer rate tends to be low. So, we address the problem of students not being able to use diagrams successfully, even when they constructed diagrams spontaneously. However, the component of instruction necessary for diagram use mastery remained unclear. Therefore, this study was aimed at clarifying those components. We hypothesized that producing a diagram would not always result in improving the correct answer rate because of lack of diagram use skills. And the aim was to elucidate the physiological mechanism of acquiring the skills by measuring blood flow in the brain using functional near-infrared spectroscopy. The experiment was conducted in 4 sessions. At pretest 1, there was no instructional training. At pretest 2, the participants were asked to use a table. The third session was the intervention session of table use training instruction. During the post-test sessions, participants were only given programs to solve. First, the behavioral results show that only asking is not enough, and that training is a necessary teaching component for diagram use. In the pretest 2, the correct answer rate did not change even though table use increased. In the post-test, table use finally led to an improvement in the correct answer rate. Next, we can see the surprising effect which only 30 minutes of training brought about in the brain. In pretest 2, the decrease of blood flow in the dorsomedial prefrontal cortex might indicate participants' lack of knowledge about how to use a table. In contrast, in the post-test, the increase in the blood flow in the left ventrolateral prefrontal cortex might indicate memory retention, and that in the left dorsolateral prefrontal cortex might indicate cognitive control. Finally, we would like to share the conclusions. First, the behavioral findings show that training was a necessary teaching component for diagram use. Second, a measurement of brain activities gave us physiological evidence for the acquisition of skills. Third, this study provides a useful model in which behavioral and neuroscientific findings were integrated to enable better understanding of what really happens when people learn and develop skills. Thank you for listening. Please read our summary paper and don't hesitate to contact us if you have any questions at all.